Welcome to the session Driving Evidence-Based Decision-Making. Today we will hear from members of the Kentucky, Ohio, New Jersey, and Wisconsin Democratizing Our Data Challenge product teams. They will share how their data products are being used by agency personnel and policymakers to improve evidence-based decision-making. We'll start with the Kentucky team, so I will turn it over to Angie.
That I always forget to put my name on my slides, but I'm Angie Tambari. I am part of the Kentucky Center for Statistics, and if you don't know us, we have the Kentucky Longitudinal Data System and the Kentucky Labor Market Information Office within the same agency. So today I've been asked to talk about how projects are used to make decisions, along with some of the collaboration that's happened along the way. In order to talk about that, we're going to have to talk about how we got there. Next slide, please. So I want to first situate this in the overarching educational workforce pipeline, because today you're going to hear from me and a couple of my colleagues, and we're each going to be talking about different pieces that we've broken off from this educational workforce pipeline and kind of taken the lead on expanding so that we can all share what we've learned and work together on how to build into it. And the part that we started on with the help of our partners in Ohio, Indiana, Tennessee, and I am forgetting people right now. No, that's the start. Later, New Jersey, Rhode Island, Virginia joined us. But starting with them, we started with the multi-state post-secondary report. I want you to note I've got this gold arrow over here, which is showing you that as much as I put K-12 up here because it's important, we're not actually talking about that section right now. And we're going to talk about, to get to how it's used, we're going to talk about how it came to be. So next slide. So back in 2017, prior to this OSU bit that has been discussed just now, the training, we had a Kentucky-only post-secondary feedback report that we just turned into an interactive report. And we had a lot of people that would reach out to us during these products, and they would ask us questions like, hey, we see that 71% of your education majors are employed, but only 46% of STEM majors are employed at the same time. We hear from our workforce agencies that they can't find STEM majors. So can you explain this for us? And we have a lot of intuitions about what's happening, but we can't actually quantify it at this point in time. So we could discuss the idea that, well, you can find jobs for education majors across the entire state. Absolutely every place needs K-12 teachers, that you have people, much like healthcare, but STEM majors may have to find a city center to find a job before the era of remote work. So we could discuss this, but we could not particularly tell them exactly how powerful this was. So questions about majors existed. Next slide. And also questions by institutions. And these are going to be kind of similar in nature in that we're reporting something that's accurate. But just because it's accurate doesn't mean it's not misleading. So we had a lot of, like, University of Kentucky is right in the central here. And so it tends to pull people in and have a pretty good employment rate. And overall, we could find 53.8% of our graduates 3 years after as employed in Kentucky under our UI wage system. But in KU, which is on the border and a big part of this integrated Cincinnati metropolitan statistical area, they could only find 38.5% of their graduates. So they might call us and ask us about how we could phrase this to make this easier for them. Next slide, please. And we knew that the borders were poor. So as you do when you do not have the information you need yet, we would try and figure out what other information we could bring in to start to explain what's probably happening here. And the things that we could do were look at the commuting patterns, where people live and where they work, to see where we might see a lot of transmission, where your graduates might still even live here, but you wouldn't be able to pick up their employment. So when we looked at this, and this is leveraging the LEHD data set, we could see that we're probably pretty important to Indiana because they have a lot of people who come over to Jefferson County or where Louisville is. And Ohio is very important to us when we're trying to put these pieces together. So knowing that, we could kind of explain without explaining what might be happening. But after the Ohio training, we held our own training and started working on piloting something with our partners. Next slide, please. So the first this is actually the second iteration of what came out, was us getting a bunch of groups together. So you'll see this pattern of trying to get something out that we can get feedback from our partners to talk about group size and what we can show so that we can figure out what questions can actually be answered because we have to find the intersection of what we need to know and what we can answer before we can make a useful product. So here we had really high level information, credential, major, and state origin, and Kentucky institution. And when we did that and also flipped it to Ohio, we got to pilot how this code might switch and what other steps we needed to take to make this sustainable in the long run. But we also got some information out of it that was informative for some of our border institutions. Next slide, please. So this is where we can see all Kentucky institutions and Northern Kentucky University right after we've gotten some additional information in here. So from before, we had about 53.8% of employment found. Now we have 68% of graduates that are employed. So we've gone up. And so overall, everybody in the state probably needs this information, but it's particularly impactful here for our border institutions. And that's really the places that mean that this report is very important, because very particular institutions are being impacted. And that's something that we need to help with. So Northern Kentucky University, we have 78% employed. And this is about 40 percentage points higher than we were able to find before. And that's more than double their employment. So this is a pretty important piece that finally agreed with what they had been telling us. And we knew to be true from their surveys, but we could not provide the data before this to actually say, yes, we can show what's happening here. Next slide, please. So this brings us to a little bit of how this is situated and who this is for. And this same report has different sections that are kind of geared towards different groups. So the employment by institution, when you look at this, you're really getting an idea of these big groups by the institution. It starts to help them fill in the gaps for their own reporting with an understanding of what's happening to their graduates. It also could be a place to figure out where do you need a survey if you're looking there or something like that to fill in your alumni surveys. Employment by demographic is almost a higher level piece. It's breaking it down with taking out the institutions that we have enough people, because there are aspects of demographics in which Kentucky's rather homogeneous. So it allows us to present more information about how different groups are doing afterwards. And that can have an equity lens and be looked at by kind of policymakers or higher level stakeholders. And then the employment by major can serve two distinct groups. Probably more. I'm going to list two that can be served. One of them is for future students, because it goes down to a 6-digit zip code. And it's saying, what are your employment outcomes 1, 3, and 5 years after, as well as so the employment rate and the wages. And when you do that, that can help people decide, where do I want to go and where do I expect that, how much might I be able to earn if I look like other people who have done this before, and if things stay the same. Another place is for the workforce, when they're curious what's happening. So in terms of STEM majors, there might be a curiosity about, what are people being paid on average if they exit the state? Is it just that there's a huge gap in what we're paying? We're not accounting for difference in cost of living. So there are lots of open questions that we can move on. But just in terms of, might somebody be attracted by that wage? You can get an idea. The other thing is that this opens up a bunch of questions that we haven't yet addressed, but there are some particular needs that the institutions have that would be nice to address in the future regarding, for institutions on the borders, they're going to have a lot of trouble getting the information they need for accreditation. And that's a key stakeholder. So that's something that we'd love to look for in the future, is how to get this information on series of cohorts that graduate, that they might make programmatic changes and they might want to see the effect on. So that's a future potential direction. Next slide, please. So I'm going to keep coming back to this and keep complicating it, because that's what I like to do. I've added in post-secondary completers, because all of this has been completers and what happened to completers. So part of our project was extending this and saying, there's a group that we may not have touched on yet. Next slide. So we started to split this into post-secondary enrollment and post-secondary completion, and then workforce. So saying there's a group that enrolls, they complete, and they go into the workforce. There's a group that enrolls, they may not complete, and they head to the workforce. And so this is where we started to pilot, again, with this idea of what groups can we even answer questions about? So how common are these patterns, and which ones can we break apart further as we continue to develop what questions do we both have and can answer with the data we have? So we want to look at who are they, how are they doing, and this sort of how common are these pathways? If we know that you started with a bachelor's or you were pursuing a bachelor's, you finish one within 6 years, what happens after? Or if you started pursuing a bachelor's and you did not finish anything within 6 years, what happened after? So that's your second question. And the third piece is really important when you start to expand your who you're looking at, because there are a lot of reasons somebody could choose to exit the post-secondary system. And we don't know what their employment patterns look like before or after. So in terms of deciding what is employed enough to be considered employment for us, we want to test out different thresholds and look at, if we say all you have to do is be employed 2 quarters and make $3,000 in a year, what does our employment look like versus if we raise that threshold and say, you should be making full-time equivalent wages, getting you closer to 13,000. And what does that do to what we're telling people about their outcomes? Next slide, please. So for this pilot, we really are looking again at what is possible. And one of the first things you can see here in how common are educational pathways is that for bachelor's pursuers, which we kind of know, it's going to be really hard to break down that less than bachelor completion within 6 years. It's a very small group. And so most likely we're not going to be able to talk to them much in any future iterations of this dashboard because people either complete it or they're not completing anything for the most part. And we also have a series of the breakdowns. So we recycled what we'd done and extended it in terms of the breakdowns that we used for the first MSPSR. As we were building this work, we used the same ones plus a few that were pertinent. Next slide, please. The next piece is for those who started, and my example here is bachelor's pursuers, and then completed either a bachelor or higher, less than a bachelor, or nothing within state within this 6-year time frame. What happened to them after? And so here we prioritized re-enrollment, which I'll talk about in just a moment. And you also had this next step of seeing whether they're equivalently kind of affected by out-of-state employment. So seeing which groups are going to be most, where we might make a lot of mistakes if we only have in-state employment is what this can start to shed light on for us. So next slide. So this highlights a piece that I want to, it's really obvious when you look at it, you say, what is happening here? Bachelor or higher and less than bachelor, why would we have such a large re-enrollment 1 year after? And so what happens is a method choice here. And this is one that we'd probably change depending on the question that we all decide which questions are most useful, is our exit year for anybody who completed was their highest completion. And so if you got something along the way and you're still pursuing, we would see you re-enroll that following year. And what we're seeing is that it seems like people are getting something along the way and they're not done trying. And you're not going to shift categories in this dashboard after that 6-year time frame. We're just following after that highest completion. But for those who didn't complete anything, we started after your last enrollment in that time frame. And the intent was for completers to say, how are you doing 1 year after this completion? But that may not be the question we want to ask. And it may be your last enrollment in this time frame. And then you can look at how the bachelor higher are doing, and they have very similar enrollment rates for non-traditional age, which is 25 and up upon first enrollment for us, and traditional age, which was 24 or younger. So they had similar employment rates afterwards. Next slide. But even though they had similar employment rates, they didn't have comparable outcomes. And the piece that I enjoy here is that because we have non-completers in here, we can see that the non-traditional age individuals had higher wages 1 year after for bachelor or higher. We can also see that the non-traditional age, as compared to traditional age, had higher wages for non-completions, which would at least turn us to the idea that this may be their employment pattern beforehand. And that could be some place to dive into the research, but it lets us know to maybe not attribute that to bachelor's or higher leads to more success, but think more about the circumstances going into this, who these people were before they started, and think about what research can happen around that. Next slide, please. And the final bit is these associate pursuers. I wanted to highlight that there are also associate pursuers in this. And here you actually have a lot more spread amongst what somebody achieves within 6 years. And this was expected as part of, we use 6 years for both because our associate pursuers, many of them look a little bit different than you expect for the traditional bachelor pursuers. You have more non-traditional students in terms of proportionally. You are more likely to have somebody who starts in the spring rather than the fall when you think about it compared to the bachelor pursuers. And you also are more likely to have part-time pursuers. So we wanted to give them a longer time frame. But here, one of the things we learned along the way was to split associate, because the intent to transfer is, at least in our state, really getting them the general core credentials that they need. And it's not necessarily going to immediately translate to workforce skills. It is designed to help you a leg up on your bachelor's. So I wanted to highlight that we have this other section and that how we classified it was based on where you started. Next slide, please. So we've talked about the sort of enrollment, completion, workforce, and these non-completers. And as we move forward, the pieces we want to start to discuss are what is the most important comparison based on, so which are core questions that we think we can answer from the data that we have based on group sizes and what we need to build in this to start answering that. So it might be an inclusion of a piece about financial aid, because part of our concern about non-completers is sunk cost and missed wages in terms of getting there. And another piece might be figuring out how to treat individuals that are, I'm going to temporarily call them undercompleting. It's not really a great term, but might be picking up a completion along the way. And how do we want to talk about that progression or trajectory? So that's a key piece along here that we'd like to discuss in the future. So this is basically a pilot report that is designed to give feedback. So the other note is for everybody on this call. If you see this and you say, I have this really important question about non-completers, or have you thought about this, please email me, let me know, and let's talk about it. And the next thing I want to mention is that I've given you this very simplified piece, and it is much, much bigger. So in here, you're going to hear from my colleagues in other states, and you're going to hear more about this K-12 piece that I haven't even touched on from New Jersey. Wisconsin is going to discuss workforce, and we haven't talked about how workforce is actually happening along this way from, around 16 on, potentially. You could be hopping in and out of this workforce. And also there are things that we haven't approached yet from our end, but talked to Ohio about in terms of how do you start to integrate these other methods of acquiring skills that you may use in the workforce, and how do you start to measure this and incorporate it into a report like this? So next slide. So I wanted to toss out these gold arrows to showcase that Ohio is going to be discussing this piece of it because they have taken the lead on this next step in the report. Thank you.
Thanks, Angie. We'll go ahead and turn it right over to the Ohio team. We'll have time for questions at the end.
Great. Well, thank you. And thanks, Angie, for an outstanding presentation and a wonderful lead-in. This is great. And again, as Angie mentioned, the Ohio Round 1 team, and I'll introduce myself, sorry. I'm Erin Joyce. I'm the Associate Director of the Ohio Education Research Center. We're part of the John Glenn College of Public Affairs at Ohio State University. Two of my colleagues are here today. I am really just the sort of a quick baton pass. Lisa Nielsen, who oversees the Ohio Longitudinal Data Archive and is a research scientist here at the Ohio Education Research Center, and a data scientist, Caroline Bartow, are going to be discussing the bulk of the technical aspects of this. But our team has been a just really fortunate to be able to build a great collaborative effort with the KY Stats team. And this is definitely a case where many people working together yield a better outcome. I realize, I think I gave 2 slides, so you can actually go ahead 2 slides, I think, Mackenzie, or whoever is advancing. There we go. Great. So as Angie mentioned, we're really focusing on building out beyond what some, sort of the K-12, beyond the higher ed aspect of post-secondary, thinking more broadly around vocational. And this is, when we say vocational here, this is adult vocational, so adult career technical education, which in Ohio is delivered by our Ohio Career Centers, as well as registered apprenticeship programs. So we had 2 big questions. What are the economic outcomes of vocational credentials in Ohio and in the region? And what are the economic outcomes of registered apprenticeships in Ohio and the region? And Angie did an excellent job and had some really great maps of showing some of these important cross-state connections. When we think about particularly vocational and adult career tech credentials, as well as registered apprenticeships, those are very important components of our workforce and workforce training and development within the state of Ohio. This is a priority for our Governor's Office of Workforce Transformation, our Department of Job and Family Services, and our Department of Higher Education. All of these stakeholders are very interested in really understanding the complete ecosystem of post-secondary education and training, and particularly tied to key industries, key regions within the state. And if you look at, similar to, as Angie mentioned, we always use the Cincinnati MSA as an exemplar of why is this work important. Cincinnati, the Cincinnati MSA, Cincinnati is of course a city in Ohio, but it sits on the Ohio River, and the MSA covers 3 states, Ohio, Kentucky, and Indiana. And people do not stay on one side of the river. People don't stay on one side of the border for both training and their careers. They move back and forth. And so for us to really understand the investments, it's important for us to know what happens to folks across the states. Are they moving back and forth? Are they getting training in one state, getting a job in Kentucky, coming back? Those are questions that are very important to us that we can only answer through the types of analyses available through this partnership, through the ADRF, and through these multi-state agreements. Similarly, if you look at a map of Ohio technical centers, why is that Indiana border so important? There's the I-75 goes from Detroit through Ohio down into Kentucky, and there are OTCs, as we call them, all along that corridor. So again, that's the I-75 is close to the Indiana border. Many of those folks who are getting credentials at our Ohio technical centers are going back and forth across the Indiana border, back and forth across the Kentucky border, and it's very important for us to understand what's happening. So in terms of the data we've been using, we are using our higher education information system data, specifically there for our Ohio technical centers, the registered apprenticeship data system, and then for the wage and employment outcomes, UI wage records, and QCEW. And with the MSPR partner states, what we're linking to are those is that employment outcome data. So we are doing, as has often been the case as the multi-state post-secondary report has grown and evolved, we start with, again, a state brings in a particular set of programs, and then we link to the other states. What we're of course hopeful is that this pilot, this model will be something that other states can adopt, and so that more states can then bring in their adult vocational credentials, more states can bring in registered apprenticeship data, and we'll be able to see, again, more states adopt this model. But could you move on to the next slide, please? So in terms of what we're measuring, we are looking specifically at measures of educational training and completion. So similar to what Angie was sharing in the previous slide, we want to know what is their course of study, what programs are they concentrating in, and attainment of journey status for those registered apprenticeships. We're interested in measures of program quality, so things like time to completion, the length of the program, industry of employment, and the occupation of employment. So these, again, are all questions that we get asked a lot by our state agency partners, different program leaders, and policy leaders around the state. So these are the measures that folks are interested in. And then for measures of economic outcome, we're looking at quarterly earnings, annual earnings. We have a potential to explore hourly rates of pay for apprenticeship completers, but that's more of a bit of a stretch goal there. But those are the main outcomes. I'm going to turn it over to my colleagues. So as I've laid a bit of the groundwork and they are the actual experts doing the work. First, I'll hand it to Lisa Nielsen, who will be talking about data access.
Sure. Hi, I'm Lisa, and this for any of you who have worked, to this point in a project yet in the ADRF, this should look pretty familiar. We've got the legal mechanisms are really a combination of the Coleridge requirements for getting into the ADRF, as well as our state-specific agreements. And so we did complete a process of having written approval from ODJFS, the Ohio Department of Job and Family Services, and the Ohio Department of Higher Education to specific to this project to allow our analysts to access the data for this project. And that consists, so we completed an Ohio-specific data use agreement, and then also the Kentucky non-disclosure agreement to be able to work in the same space as the Kentucky-based data. And then, as everybody does, we completed the ADRF terms of data use and security training. The the Ohio data is available through the data sharing agreements with the Coleridge Initiative, in that there's sort of a two-tiered process. One is that there's some basic governance that needs to be established between the Ohio-based state agencies and the Coleridge Initiative to have the data available. And then the second tier is that project-specific permissions that I just described. So that's really the legal mechanism that we followed. And then technically, we went through the steps to get access to the secure space and working with sensitive data. And we coordinated that with Angie's team, because it is, as she showed, that sort of crossover slide where there's a baseline of work that's already happening, and we're kind of building onto that and extending it. And so we worked with Angie collaboratively to get into this, to be able to share space with her team, just following the regular steps that are followed through the ADRF. The analysis is being done in R, and that's just really an analyst choice in this case. And the way we're physically being able to make this happen is that the same unique identifier has been applied across all of our data sets in Ohio as are being used for the rest of the multi-state dashboard. So we're using a consistent method there that allows us to match one record from another, both over time and across states. And the next slide, I'll turn it over to Caroline.
Hello, my name is Caroline Barto. I am the data scientist doing a lot of the work for the two dashboards. And we are deep into development for these dashboards, but since our data providers have not yet approved the results, we will be looking at mock-up designs that use fake data for this presentation. The first section of our dashboard is heavily inspired by the apprenticeship report from KY Stats. We will be showing the count of completers for both OTC courses and apprenticeships. And for the OTC completers, we will also be showing the count of enrollments completed and the count of credentials earned. Users will be able to select the outcome year and grouping variables to see results by. Grouping variables include completer demographics such as gender, age, and race, and program characteristics such as program industry or course major group. Next slide. The second section of the dashboard is inspired by the multi-state post-secondary report. And for OTC credential earners and apprenticeship completers, we will be observing their economic outcomes in the 10 years since completion. On the left, we are showing the percent employed, and on the right, we are showing the median annual earnings adjusted for inflation. If we are able to show the results by in-state or out-of-state status, we will, but if not, because of redaction issues, we will still present the information for the group as a whole. And you can see in year 4 and year 6 how that will be shown. And below those tables, we will also show additional summary statistics that will be dependent on the program that we're looking at. For example, for the apprenticeships only, we also call them rapids. It's the rapid system that you see on the slide. We'll also be showing the percent employed in the same industry as their program. Users will be able to select the completion year and also the type of credential that they earned for the OTC completers. Next slide. So this analysis greatly benefited from collaboration with KY Stats. To start, their technical documentation helped us to make decisions about creating grouping variables or our redaction strategies. And also, since we had the Ohio data in-house, we could also get started on drafting the analysis prior to getting access. And that helped us to get started right away once we were there. I also met bi-weekly with Angie Tambari, and her experience and perspective was greatly appreciated in getting the analysis to be consistent with other views in the MSPSR. And she also shared code with us, including the code and reference files to adjust wages for inflation to match their methods. And as I've said before, their dashboard designs helped us to build our own. Next slide. So our immediate next steps is to finalize our results and dashboard design. This includes getting agency review and applying their feedback, and also adjusting our mock-up designs to be accessible. Later on, we will also update our Ohio data to include more recent years and also incorporate wage data from other states.
Thank you. Thank you all, Erin, Lisa, Caroline. We will go ahead and move on to New Jersey now.
Hey, good afternoon, everyone. Good afternoon. I'm Jimmy Green from New Jersey, the John J. Heldridge Center, and today we'll discuss the K through 12 data model and how it applies to the teacher workforce. This model provides a comprehensive framework for organizing and analyzing educational data, and I'll guide you through the theoretical application, focusing specifically on the teacher workforce data. So here's our roadmap of today's presentation. So I'll provide an overview of the K through 12 model and its foundational elements. Then we'll explore the application of the STAR schema in this model and how it enhances data organization and analysis. And then finally, we'll go through a practical use case. So moving on. So our K through 12 data model brings organization to, can you go back to the previous slide? So our K through 12 data model brings organization to data from various sources, schools, students, staff, and agencies, enabling a comprehensive long-term analysis. So it helps us track important metrics like student outcomes, trends in the teacher workforce, and even program evaluations by pulling data from multiple systems. It supports robust reporting and deeper insights. But when we first embarked on this project, our goal was simple: to build an integrated data system for New Jersey that would streamline how we manage and analyze educational data. But as we worked through the process, it became really clear that the landscape of educational data varies widely across states, which made building a system with only New Jersey in mind too narrow. And that's where the Common Education Data Standards, or CEDS, came in. CEDS provides a standardized framework that ensures consistency when sharing or comparing data, even across states. And it's not just about making data uniform, it's about ensuring that data from different systems can actually work together, making collaboration and multi-state insights much more feasible. So recognizing this, we pivoted. Instead of creating a tool limited to New Jersey, we aim to develop something scalable and flexible that any state could adopt and adapt, whether it's used for tracking teacher retention, student outcomes, or evaluating educational outcomes. This model theoretically can accommodate a variety of needs, while ensuring that the data is organized for quick analysis. So moving on to the next slide. To get a bit deeper, here's the K through 12 data model and how it supports a range of use cases. So first, it connects data across different schools, programs, and students. And this creates a unified view of how educational components interact. Second, the model also enables detailed longitudinal analysis by integrating data from various sources. It allows us to track outcomes over extended periods, offering a more complete picture. And this model is flexible enough to address different stakeholder needs, such as examining student success or workforce trends. And the beauty is really in that it's not just limited to one domain. It can be applied across various areas. And as mentioned before, it's based on CDS. So we're ensuring that the data coming from various systems can communicate and enable integration as well as interoperability. On to the next slide. So next, let's explore how the K through 12 data model is structured. So we'll start with these two complementary views, the full conceptual model and the dimensional model. The full conceptual model showcases the high-level relationships between entities like students, schools, assessments, and agencies, whereas the dimensional model is where the STAR schema comes into play. It breaks down the data storage into fact and dimension tables. For example, fact tables such as student enrollment and dimension tables like courses or staff allow us to efficiently organize and retrieve data for longitudinal analyses. Next slide, please. So here's the K through 12 full conceptual model in detail. This view shows the core entities within the educational system, including organizations, local agencies, schools, staff, students, courses, and so on. It emphasizes the relationships between these entities, showing how, for example, a local education agency connects with schools and staff, or how assessments are administered to students through standardized tests. So this model helps illustrate how we track interactions between different educational elements over time. Next slide. And here is a detailed view of the K through 12 dimensional model. So as you can see, this model is built around the STAR schema with key fact tables like student enrollment at the center and dimension tables such as students, courses, staff, and programs branching out. This structure allows us to efficiently store and analyze educational data by separating facts like enrollment counts or student assessments from dimensions like courses and schools. We can easily query the data without needing to perform complex joins. And this is essential for longitudinal analysis, where we need to track how different factors like course completion or staff retention change over time. Next slide. discuss. Next slide, please. So in viewing the current approach, the SODS data warehouse is designed to efficiently store longitudinal data across different domains. And while this is great for long-term storage, it's not optimized for quick cross-domain analysis. For example, if we want to analyze trends like teacher retention across different demographics or student outcomes, we would need to pull data from different unconnected sources. And this lack of integration makes it challenging to conduct complex queries efficiently. So as a result, the current approach can be slow and difficult when attempting to answer broader multi-domain questions. Next slide, please. So to address these challenges, we can further utilize the STAR schema, which I've already introduced as part of the K through 12 dimensional model. So this widely used structure is designed to streamline querying and reporting. At the core of the schema is a fact table where key metrics like teacher retention or student performance are stored. Surrounding it are dimension tables such as teacher, student, and school, which provide context for those metrics. The strength of this schema lies in its ability to simplify queries and minimize the complexity of joins, making data retrieval much faster. So we can analyze how teacher retention varies by school, subject, or demographics. And the structure also enhances the organization of data, ensuring that all related information is efficiently connected, allowing for fast and comprehensive analysis. Next slide, please. Now, let's look at the STAR schema and how it can be integrated into the existing SODS system. First, we extract the necessary data from the SODS, such as teacher workforce, student demographics, and school data. The next, we organize the data into a STAR schema with the fact teacher workforce at the center, connected to dimension tables like teacher, student, and school. Finally, we load the STAR schema back into the SODS for efficient querying. This adds an analytical layer to the system, allowing us to answer more complex questions. So this integration turns a storage-oriented system into a high-performance analytical tool capable of handling multiple domains. Next slide. So moving on to a use case, the teacher workforce. For a practical example to demonstrate how the K through 12 model and its STAR schema can be applied. So the purpose here is to leverage the STAR schema to analyze things like teacher retention, workforce diversity, and subject specializations in a faster, more accurate way than traditional state data systems. So let's break this down on the key metrics. So like retention rates, for instance, tracking year-over-year retention is important for workforce planning. And the K through 12 data model enables states to identify trends early and make data-driven decisions to improve retention. Demographics, ensuring workforce diversity is key. So this schema allows states to easily break down data by race, gender, and age, providing a clear view of how our workforce reflects student demographics. And then finally, subject specializations. This schema helps us pinpoint subject shortages, especially in critical areas like STEM, allowing for more targeted recruitment and training. Tools like SQL, Tableau, and Power BI allow us to analyze and visualize data from the STAR schema in real time, This eliminates the need for slow manual data extraction processes and ensures that insights are available much faster. For example, in New Jersey's teacher workforce report, we'll use the STAR schema to analyze retention rates over the past decade and identify subject shortages, so we can proactively target areas for improvement. So by using this tool, we can generate faster and more accurately than traditional methods. So before we conclude, just a few takeaways. So the K through 12 data model, especially the STAR schema, provides a framework for organizing and analyzing large-scale educational data. And by adopting this model, we hope that states can gain quicker and deeper insights into areas like teacher retention and workforce diversity, streamline data management processes, making analysis easier and scalable, and finally, enhance workforce planning by identifying gaps in specific subjects or regions. So looking ahead, integrating this model into systems like New Jersey's SODS can provide real-time actionable insights that allow states to plan proactively, moving away from static manual reports. Thank you for your time.
Thanks, Jimmy. Last up in this section, we have Ellie from Wisconsin.
Thank you. Our journey with Coleridge and the ADRF towards the Democratize Our Data Challenge started back in 2021 when myself, my colleague Brian Hipsch, and other colleagues, Tom Walsh and John Westbury, took the 2021 Applied Data Analytic class, Employment and Training Administration, or ETA class, where we got to go in the system and learn of Illinois' employment to reemployment portal, how they utilize that information for workforce planning, especially during COVID when the workforce dynamics were changing at such a constant, quick basis by tracking UI claims over time across region, across demographics, and the other pieces. And so part of that class is you also get the opportunity to explore the data and look at other ways to utilize the data. For example, we were looking at differences in stay rates and how that looked by within different industries, specifically education, and the predictability of the need for additional services, such as RESCA services, through some machine learning. And so we learned a lot in that class. And so when the Democratize Our Data Challenge came about, we really decided we would like to take advantage of one of the features within the multi-state collaborative made possible through the ADRF, and replicate the code that Illinois was using for the unemployment to reemployment dashboards, and make our own Wisconsin dashboards and provide those to our local economists and local workforce boards. One of the things we had to figure out, and one of the key pieces to our Democratize Our Data Challenge, was how to host the dashboard. So Illinois did the data work within the ADRF, but then actually hosted the dashboards in a password protected environment outside of the ADRF. We worked with Coleridge to actually host the dashboards within the ADRF, protected through getting the data sharing agreements and the non-disclosure agreements for those accessing the dashboard. So folks not necessarily accessing all the individual level data, but the dashboards themselves and being able to utilize those dashboards for workforce planning and the like. And so identified a way to set that up right within the secure ADRF environment. So now workforce boards have access to seeing changes in UI claims more quickly. Our local economists often got questions from the local areas, from local partners about more recent changes by workforce development area, by region. Do we see more UI claimants by different industries, by different occupations? And then more recently looking at the equity across UI claims, but also in within the workforce. So looking at differences in race, ethnicity, disability, veteran status, education level. And so we have those dashboards available at the regional level across those different factors. In addition to doing building the dashboards, we also hosted a Wisconsin Applied Data Analytic class. A big piece of that was to provide more training to our local staff. There was 4 of us who received the initial training. We wanted others to be able to access not only our UI claims data, but we also put UI wage data in the environment as we're planning to build some additional dashboards through our UIPL equity grant to look at equity trends further, so building additional dashboards through that grant. And so we also have the UI wage data in there. And so there were, and then invited other states to join the class for their own learning and replication as the key feature of the multi-state collaborative, the Democratizing Our Data Challenge, and the like, is to be able to share across state agencies. And so had our own course. There was a lot of interest in the UI wage trends and things. So there's information, of course, through QCEW that looks at mean wages by industry, by quarter, but by having the individual wage data could ask some more detailed analytic questions, and then looking at that in combination with the UI claims data. So some really interesting projects that came out of the Wisconsin ADA class. And then, as I mentioned, we also have the Promoting Equitable Access to Unemployment Insurance Compensation through the UPL Equity Grant, and we're building additional dashboards. So those dashboards include looking at stay rates, how long folks are staying on UI by demographics, education level, industry, occupation, seeing differences, right? So you can look at the number or the volume, but you can also look at the duration. We're also looking at likelihood to claim. Does that vary by those variables? The financial trajectories, so the pre-UI wages, the UI payments, and then the post UI wage payments, and then the time from claims to reemployment. So building out through by April 2024 some additional dashboards to get at some of the additional workforce pieces. Next slide. In addition to do some of that work, so I had mentioned we have the UI wage and the UI claim data. We have actually added a couple other data sets to do that work. So one is the worker adjustment and retraining notice, or WARN. So given a certain number of layoffs, companies have to produce a WARN to let folks know that this is happening, and we can deploy our rapid response team to support the workers who are getting laid off. And so when we're looking at likelihood to claim, we can look at specific company with WARN notices and seeing how likely employees in that company are claiming UI. Are they going straight to jobs, or what do we see in the data? We're using the state directory of new hires, so to look at the time to claim to reemployment. We're looking at enhanced UI wage, so adding the industry information and some more information from the employers. Enhanced UI claim data. We've been working a lot on data cleaning and quality with our UI claim data, so improved data in that sense. And then adding also some service data, so our employment training programs, what services are our UI claimants connecting to. And then some future development that we're looking at is further training of our workforce boards and using those dashboards. So we've got some out, they have access to it. So more additional support on training, workforce development, potentially looking at other types of dashboards like additional trends with UI wages that can help with workforce development strategy. And having more input from the local workforce boards on our dashboards to make sure that they address local workforce development and training related issues. We've also been in conversations with our Bureau of Workforce Training on how potentially to use the data, dive in more by employer for possible layoff aversion strategies. So seeing trends maybe that aren't identified through WARN, but an increased trend in UI claims by certain in certain areas, in certain industries, in certain occupations, or within a certain employer, and how the rapid response team or other workforce supports can reach out and support employers, maybe to avoid a larger layoff situation through some layoff aversion strategies. So being having more data to make informed decisions in that area. Next slide. So the impact, what we've done, we've trained 25 staff. We have new research questions that are popping up as folks are looking at the data, looking at the dashboards. There's questions on things like the impact of the UI claimant experience itself, industry switching. Are people going from one industry to the next? Or are they mostly staying within industry? I think post-COVID, there was a lot of talk of industry switching, especially away from food and accommodation. But then some exploration that we did saw maybe a little less than you heard anecdotally. So maybe we were hearing the exceptions. And so one question folks had is how easy is it to go from industry to industry, and what supports folks might need to do that, especially thinking about career advancement and good job opportunities. There's been a lot of focus in Wisconsin. Our governor had the AI workforce task force and recently sent out an action plan. And so we've been diving into the data on the effect of AI on the workforce, what kind of layoff aversion strategies we might determine that might be based on industries adopting new tech, including AI, making sure equitable access to jobs and experiences and trainings, and also looking what the other states are doing, right? So the multi-state collaborative allows us to see what different projects and things are happening. So for example, Ohio, in partnership with Michigan, has a project that's looking at how following researchers in AI, researchers in electric vehicles, and seeing where they end up in the workforce. So seeing where those researchers, what jobs, what industries they end up in to see the impact this type of training is having on the workforce. So that's a different way to look at things. And I know the University of Wisconsin-Madison is one of the universities they partner in there. And so we might be able to look at trends, the influence of AI on the workforce, even more so partnering with that type of project. So it's called the Industry of Ideas. So that's one opportunity we've looked into. And then finally, we're in conversations with our K through 12 partners on better looking at across education and workforce, specifically career and technical education, and being able to link data across the systems. Biggest challenge when we talk K through 12, they don't collect SSN. So can we utilize our matching ability at DWD with our identity insight matching, as well as using the State Directory of New Hire, which has name and date of birth that could allow for matching, especially for new folks entering the workforce, and then matching that over to UI wage, getting that matching in place, and then hashing and putting in the ADRF to then look at trends. So we're in early conversations, hoping to think about how we might better look across education and workforce. And then also looking at the ADRF for data sharing efficiencies. So we have data requests from different partners, including outside partners, and how to more securely share. So the ADRF is FedRAMP certified, and there's this, well, we don't, who gets whose data? Well, with the ADRF environment, no one gets anyone else's data. Instead, it's an environment where data can be linked in a common data space, and security put in place. So you're only pulling out the results of the analysis. And so working through how we can best meet some data requests from different partners, maybe more efficiently by utilizing the ADRF through a university that's not a Wisconsin University, Medical College of Wisconsin, and even looking at local workforce boards or other local partners who got a workforce innovation grant. So looking for data sharing efficiency opportunities by having all these data within the ADRF. Next slide. So the way that we're able to do this, and I'm going to go through this real quick, is we here in Wisconsin, we developed evidence-based infrastructure to make evidence-based decisions, our workforce data integration system, which was built through the Workforce Data Quality Initiative. And we have staff data governance processes and tools that help us do that. So myself, my colleague Brian, I mentioned earlier, and then embedded researchers and research evaluation team within the department, but also in partnership with outside researchers as well. We utilize a learning agenda and evidence plan to drive our research projects based on DWD's mission and our WIOA state plan. And we've got a variety of tools where we do that through our longitudinal workforce database. And we see ADRF as a key tool as well. Just a couple examples, and then disseminating our findings online to local workforce boards and other partners through our website. The link to a website is on the slide. Next slide. And then this is just an example of additional questions that have come up through our local economists and other partners, and having access to these data and these dashboards are allowing us to better answer these questions more readily. So looking at trends in hiring and layoffs across different parts of the state, Where are folks looking for workers? Where are the skills in high demand? And a variety of other related questions. Looking at UI wage to see the percentage or proportion of those who have wages that are considered self-sufficient or family supporting wages, and then changing industries and occupations, and answering questions, helping workforce boards or other partners answer questions to get grants and the like. All of these things have come up, and developing this infrastructure has made it easier to answer those questions and to partner with local partners, but also with other states as well.